This is my third video about motion, and it's about falling due to gravity. Acceleration due to gravity 9.8 meters per second squared. So ignoring air resistance, everything falls at 9.8 meters per second squared. It doesn't matter what its mass is. You know, if fat bloke and skinny bloke jump off a cliff together, they have the same acceleration, ignoring air resistance. Why? Because the force acting on each kilogram of them is the same. It's 9.8 newtons, but we'll worry about F equals ma later on. Basically, remember 9.8 meters per second squared, and you'll be told little g in the, well, it's on your data book. Okay, an experiment you should know is how to go about getting a value for little g. There's several ways of doing it. The way that I tend to do it is using some kind of a timer, dropping an object, perhaps being held by an electromagnet. It falls a certain height and hits some kind of a switch or a pressure pad, and then a device measures the time accurately. Do it for a range of heights, and looking at h equals a half gt squared, which comes from s equals ut plus a half at squared. If you plot a graph of 2h against t squared, then the gradient will be little g. Imagine a car drives off a cliff. What will its path be in the air? Well, if it drives off a cliff, it will become a projectile. And the path of a projectile is called a parabola, path of a projectile. Okay? In physics, we need to remember that basically whatever's happening horizontally and whatever's happening vertically, we can consider separately. And horizontally, the velocity doesn't change, ignoring air resistance. Its velocity is constant. Vertically, it will accelerate due to gravity at 9.8 meters per second squared, and it just becomes a Suvat equation. Okay, a car drives horizontally off a cliff of height 25 meters at 30 meters per second. How long will it take till it hits the ground? What horizontal distance will it travel? What will its velocity be when it hits the ground? Okay, if you want to have a go by yourself, answer in a couple of seconds. Okay, so what we do is we say vertically, h is a half gt squared, gives us a time of 2.3 seconds. Then horizontally, it's just distance is velocity times time. We know what the time is now, so we've got the distance. Its velocity when it hits the ground, well, what we need to do is get the vertical velocity, 22.5 meters per second. The horizontal velocity is 30, and add them together with Pythagoras, 37.5 meters per second. And you might have to get the angle as well, just a bit of trig to get that. Here's another one. Usually you'll get a horizontal projection. In other words, something like a car driving off a cliff. Not necessarily though, we'd better have a look at this. A ball is thrown with a velocity of 20 meters per second at an angle of 70 degrees to the horizontal. Here's a diagram of what's going on. What height will it reach? How long will it spend in the air? How far will it travel horizontally? So the first two parts of the question are just looking at what's happening vertically, using the vertical component of its velocity. And then when we know the answers to those, we can figure out the range of the projectile, how far it travels. You should have a go at this for yourself. I'll show you the answer in a couple of seconds, and it is